On September 12, 2025, astronomers detected something that shattered every expectation of how the universe behaves. A colossal object blazed in from the darkness of deep space, dragging a tail so immense it stretched across the sky 5 times the width of a full moon. Even amateur stargazers could see it with modest backyard telescopes. Within hours, the verdict was clear: this was no ordinary comet. It was far brighter, far larger, and far stranger than anything humanity had ever recorded. Officially, it was catalogued as C-2025 R2, but the world quickly gave it another name, SWAN. Yet what froze scientists wasn't just SWAN's size or brilliance. It was timing. Because at that exact moment, another object, already infamous among astronomers, was racing toward the Sun from the opposite side of the sky. 3I, Atlas, the third known interstellar visitor after Oumuamua and Borisov. Both were inbound. Both would reach their closest approach to the Sun within the same 10-day window. Both would vanish into the solar glare during their most critical moments. And both displayed behaviors that defied every known law of celestial mechanics. The odds of such synchronization happening by chance were so small that many quietly stopped calling it coincidence. Some began to whisper another word instead: mission. If one interstellar visitor was strange enough, the arrival of a second, 100 times larger, aiming for the same solar corridor, suggested something far beyond coincidence. What first stood out about SWAN wasn't just its scale but its composition. Instead of the usual dusty ice, its reflective signature revealed traces of nickel and cobalt, metals associated not with natural comets but with engineering. Some researchers started calling it the fortress, because while most comets crumble under solar stress, SWAN seemed to endure it. Its brightness curve remained constant, its structure appeared intact, and its immense tail pulsed with rhythmic precision, like controlled microthrusts, not chaotic vapor trails. It was as if a skyscraper-sized machine was gliding through space, shielded by an electromagnetic barrier, deflecting the fury of solar wind. But if SWAN was the fortress, Atlas was the drone, smaller, agile, unpredictable. It darted, flared, and shifted color in ways no natural object could. Together, they didn't look like cosmic accidents. They looked like parts of a system, two components of a single, synchronized design. And when astronomers plotted their arrival vectors, the picture became even more unsettling. SWAN approached from Aquarius, Atlas from Sagittarius, origins separated by over a quarter of the celestial sphere. Yet both entered the inner solar system at nearly identical solar distances, reaching perihelion within just 3 days of each other. Then came the blackout. From October 8 to October 18, both objects disappeared behind the Sun. During that time, all optical observation became impossible. For 10 days, humanity's eyes were blind. And that was when the two objects would be closest to the Sun, and possibly to each other. The coincidence was too perfect. Some scientists began to call it the corridor, a narrow band of space and time where their paths converged with precision that defied randomness. The pattern was so precise that a few dared to suggest what no one wanted to say aloud: this might not be a natural event at all. Energy readings deepened the mystery. Atlas's bursts of acceleration already required more power than 10 nuclear reactors. But SWAN eclipsed even that. Its total energy output surpassed 10,000 gigawatts, greater than the combined electrical generation of all civilization. No natural body should produce that kind of stable, sustained luminosity. Its pulses were regular, its signals patterned, almost deliberate, more like a transmission than a flare. Soon, whispers spread through observatories. Maybe SWAN wasn't a comet at all. Maybe it was a beacon. Then came the silence. NASA, ESA, and ISRO simultaneously restricted real-time data access. Public feeds were paused. Requests for high-resolution imagery were denied. The official explanation was solar conjunction safety, but internal memos told a different story: teams reassigned, observation schedules rewritten, radio windows shut down. Leaks suggested one reason. Whatever was happening during the blackout, the agencies didn't want the world to see it. But others refused to remain silent. Independent astronomers in Spain, Chile, and Japan formed underground data-sharing networks, pooling their fragmented readings. The more the authorities hid, the louder the independent voices became. By mid-October, the whispers had evolved into a theory. SWAN wasn't a lone traveler, it was a returning one. Its orbital period appeared to be roughly 22,500 years. The last time it would have passed through the inner solar system was near the end of the last ice age, around the time early humans carved the first symbols into stone. Ancient monuments like Göbekli Tepe suddenly took on new meaning. Some of its carvings, spirals, animal constellations, strange radiant disks, could now be reinterpreted as depictions of a blazing visitor that once dominated the prehistoric sky. If SWAN had been here before, then its return might not be random at all. It might be part of a cycle older than recorded history. Behind the scenes, there were rumors of a classified probe, launched quietly from an orbital platform, armed with high-energy sensors and radar designed to penetrate SWAN's tail. It never returned. Its last transmission showed what analysts described as a reflection, a perfect mirror image of the probe itself, as if something had scanned it back. Seconds later, its signal vanished behind what engineers called an energy lattice, a kind of plasma barrier similar to a Faraday cage. If true, that would mean SWAN wasn't just massive, it was aware. Spectroscopic data from the James Webb Telescope added another layer of unease. Instead of chaotic ice and dust, its tail contained structured organic molecules, polycyclic aromatic hydrocarbons, the kind often found in prebiotic chemistry, but arranged in patterns too regular to be random. To some, this hinted that SWAN wasn't merely a fortress, it was a carrier, a seed ship engineered to preserve and distribute the building blocks of life. Atlas, then, could be its scout or messenger, collecting data, transmitting updates, ensuring the path was clear for its return. As the blackout window deepened, those tracking the orbits noticed something else. SWAN and Atlas were converging, not just toward the Sun, but toward a shared vector that would bring them into near alignment before they vanished from sight. Some called it a rendezvous. Others, a refueling event, perhaps using the Sun's radiation as an energy node. But one idea unsettled everyone. Maybe they weren't meeting each other at all. Maybe they were meeting us. For thousands of years, humanity lacked the instruments to notice. But now, for the first time, our telescopes, our sensors, our probes, our attention, were focused. And that might be the trigger. Soon after, Webb detected something extraordinary. SWAN wasn't just reflecting light, it was emitting radiation in a frequency band almost silent in the natural universe. Pulses between soft X-rays and gamma rays, structured, repeating, coded. The emissions occasionally overloaded ground sensors, even disabling one experimental telescope array in Australia. Engineers described the interference as deliberate jamming. For the first time, some began to fear that this wasn't a passive signal. It was control. Then came the most shocking discovery. A powerful burst of radiation from SWAN was detected heading not toward Earth, but toward the Moon, specifically toward a region rich in gravitational anomalies known as mascons. For decades, those anomalies had puzzled geologists. Now, scientists asked a new question. What if those regions weren't natural at all? What if they were remnants, receivers waiting to be reactivated? In the days that followed, something changed on Earth itself. Magnetometers across the globe began registering rhythmic pulses every 43 seconds, the exact period of SWAN's emissions. Migratory animals shifted course. Whales altered their song frequencies. Even deep-sea sensors picked up low-frequency vibrations unlinked to any tectonic activity. It was as if our planet had begun to resonate in harmony with something beyond it, a forgotten frequency that had just been reawakened. By now, a new and terrifying hypothesis had emerged. What if the first interstellar object, Oumuamua, was never just a stray rock, but the lock? What if 3I, Atlas and SWAN together were the key, designed to complete a sequence older than humanity? A lock and a key, separated by centuries, now reunited in a precise celestial dance. Supporting this theory were brief, inexplicable anomalies in the Voyager spacecraft, both of which transmitted bursts of unrecognized data during SWAN's strongest pulse, as if responding to an external signal. The James Webb Space Telescope was built to look outward, to peer into the first light of the cosmos. But what it may have found instead is a mirror, showing us that the story was never about distant galaxies. It was about here. SWAN and Atlas didn't just stumble into our system. Their precision, their scale, their silence, all point to intent. And the most unsettling truth may be this: we were never the ones watching. We were the ones being watched. If these objects truly are part of an ancient mechanism, then perhaps the signal isn't what we received, but what we sent simply by noticing. Because sometimes, the moment we look into the darkness looks back. And now, the universe might finally be answering.